Okay, like one of your other questions where every so often they ask in the exam. This is another question type that pops up every so often in the exam, so I cannot skip it, okay? Your textbook also recognizes that, and it only asks you a couple of questions on this, so I need to cover it, okay? This is the only time when the curves are not going to take the perfect shape shown previously. If you are only drawing one normal distribution, it's going to look like this. If you ever want to sketch and it only asks you to draw one, it's going to look like that. But if your question asks you to draw multiple curves on one axis, you have to run these steps. The reason why is this. In methods, you guys would have been told the area under the curve is 1. And then you can use that to decide how tall and everything is. But I prefer to have a bunch of steps that just tells you how tall everything should go. So there's no faffing around, okay? So I had to develop this, and it works all the time. So these are my steps for how you draw multiple normal curves on one axis. Draw an x-axis in your drawing space with a scale that's going to fit your 3 standard deviations above or below the curves being drawn. This is the thing that I had to research. For each curve, the vertical height is 0.4 divided by what the standard deviation was. Step 3 and 4 are judgmental. This is to help you draw. Place a dot towards the top of your drawing and mark it with the biggest height from step 2 that we worked out. This decides your vertical scale for all the curves to be drawn, and then use the mean and standard deviation of all the curves to draw them. That sounds like a lot of faff. You've got it printed out. Let's demonstrate it so you can see it's not a lot of faff. So step 1, draw an x-axis with a scale that's going to fit 3 standard deviations away. So I've got a scale here, but it's not decided yet. Which one of these 2 curves that I'm being asked to draw is going to be the widest? Yes? A. Why?
Because the standard deviation for A is twice the size of B.
Good. And we decided that normal distributions go 3 standard deviations above and 3 standard deviations below the mean. So let's do some thinking. What's 3 times by 4? Oh. 3 standard deviations away, it's going to be 12. So the mean of the first one is 12. This first curve needs to go from 0 up to...
12.
No, 12's in the middle.
Oh, okay.
I need to go 12 above that.
18.
More? 24. So right now, in my head, I know the scale has to go between 0 and 24 at least. Okay? Let's do the same thing for this one, times by 3. 2 times by 3 is 6. If the mean of this one is 9, what's the lowest that curve needs to go down to? 9 takes 6? Oh, that's going to be the lowest. What's 9 take 6 going to be? 3. So 3 up to, what's the highest this graph will need to go up to? Not quite. 9, 10, add 6 to 9. 15. So now I can see the lowest number my scale has to go down to is 0. And what's the highest it has to go up to? 24. That decides my scale here. What if I did, I don't know, 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. Is that going to fit our 2 curves? That scale? Yes, question?
Why is B 3 and A 0?
B3.
Yeah.
Because a normal distribution is 3 standard deviations wide. And this tells you that a standard deviation is 4. So I'll just do a quick sketch of this one. If the middle of this is 12, and we're going to go 3 standard deviations above that, what's 3 lots of 4? 12. So it's going to finish around 24. And what's 3 standard deviations below the 12? 0. This second one, the middle was 9, and the standard deviation is 2, so 3 lots of 2 is 6. This one's going to finish around 15. This one's going to finish around 3 below. Okay? That's the thinking behind it. That's not the drawings. It's to go, I need to decide a scale at the bottom that's going to fit my 2 curves. Okay? So now we've decided one that fits 2 curves. Let's position the means. So A is going to have a mean of 12. So I'm going to draw a dotted line up from 12. Follow along what you can. This is just positioning them centrally. And then B, that's A. B is going to have a mean of 9. So there's going to be a dotted line above 9 on the x-axis. B is going to be centered over that. So we decided the scale, we placed the middles. You got your notes in front of you. What was the formula for the height of these? Sis?
0.4 divided by standard deviation.
Good. So the height of A is going to be 0.4 divided by, what's that standard deviation? 4. So it's going to spit out 0.4 divided by 4 is 0.1. We need to work out the height of B now. Height of B is going to be 0.4 divided by 2. That's going to be 0.2. So which one of the curves is going to be taller, B or A? What was the height of B? 0.2. What was the height of A? 0.1. So B is going to be double the height of A. So what did I say in your notes? Place a dot towards the top of your drawing space and mark it with the highest or the biggest step from step 2. So we just worked out that the height of B was the tallest. It's at 0.2. So you just need to put it towards the top. Why am I giving you this flexibility? Do I know what grid space you have for your exam to draw these? No. But what I know is the tallest thing I need to draw represents 0.2. So I'm going to fill up the space with that. I didn't even count those blocks. I'm just going to say that this, on my drawing, represents 0.2. And if that's 0.2, how tall is A going to be? It's 0.1. Half of it. So just eye it. A is going to be about that tall. 0.1. It just needs to be halfway down. So what we're doing is placing little guidelines for our drawing. Okay? What other guidelines can we draw? 3 standard deviations away. So B needs to finish around 3. So I'll put a little dot around 3 and finish around 15. So that's my B. My B curve is going to go between those 2 dots there. Where's the lowest that A goes? It goes from 0, around 0, to 24. So put little dots there, ready to go. The only other thing determining the shape of this was the concave between 1 standard deviation. So now we have to think, okay? 1 standard deviation for A is 4 above. So what's 4 above 12? 16. And that concave goes halfway down. So if my curve is that tall, I'm going to go halfway down at 16. I'm going to put a dot there to represent the concaveness. And what's 4 down from 12? About there. So now I can draw the bulgy bit. Concave, how do you remember? Concave, entrance to a cave. It looks like that. So I'm going to try to do my best, because this is slippery, make this concave. It's about right. And then the rest of this graph needs to be convex. So remember, A goes all the way up to 0. So from this dot to the edge, we make it convex, curve back the other way. This dot to the edge, we make it curve back the other way. That's about right. We're not going to get like a set square or like weird rulers to measure. When you have narrow ones, it's very easy to make your normal distribution look very dong-like. So erase and do it again, okay? So let's just finish drawing B. Standard deviation is 2 away. So what's 2 above 9? 11. So I'm going to put a dot about halfway up over 11 and a dot about halfway up at 9 minus 2, 7. So this one's very risky. Okay, see how narrow it's going to be? So if on YouTube a dong is drawn, I apologize. I'll erase it and start over. I need to make that look concave. It's all right. I'm sketchy right now. All right? And then the rest of it, we make it concave. So to the edge, up to here. To the edge, up to the point of inflection. Those are your curves. That is how you draw multiple curves at the same point. Okay? Why is it important to do this process? Because the area under a normal distribution always has to equal 1. So why is this shorter? Because it's wider. So that area under this needs to be the same as the area under this. This one's got a thinner standard deviation. So how is it going to have that same area? It's going to be taller to make up for it. Okay? But instead of just telling you the area underneath needs to be 1, I devised these steps to make it so you can put dots everywhere, okay, so that you can just guide it and work it out properly, okay? So that is how you draw them. There's only a couple of questions on the timeline that asks you to do that.